Which of the following functions could not be a polynomial? So it's easier to say what is not a polynomial. You can't have absolute value and be a polynomial. You can't have a function that has a variable in the exponent position, and you can't have a function that has a numerical value that's negative in the exponent. So what does cubic look like? As a reminder, this is cubic, okay? Good to go. This is quadratic, good. This is an example of linear. This is an example of exponential. And because I have a variable in the exponent position, this is the correct choice. It is not a polynomial. Which statement describes the roots of h of x equals x cubed minus 4? So I've already inputted this into decimals, and roots are talking about what are the x-intercepts. So there's only one real. Now, as a quick reminder here, imaginaries always come in groups of 2. Just know that imaginaries come in groups of 2. I need 3 answers here, 3 answers, and I can see it only ever crosses the x-axis once. Your x-intercepts are your reals, so there's 1 real, has to add up to 3. That means the other 2 have to be imaginary. 1 real and 2 imaginaries, option C. And we want to know which end behavior matches this. I think this is kind of a little bit harder to read, so what I'm going to do is we know that f of x is the same as y. So this says y goes to positive infinity as x goes to positive. And when y goes to negative infinity, we know x goes to negative infinity. What does that mean? Well, if I have a graph here, it means as I go to the far right, way over here, the end behavior is going up. As I go to the far left, it's also going down. Okay, so I'm going to go one by one, and I'm simply going to plug this in. You may already remember rules about even and odd functions and the leading coefficients, but if not, if you don't remember those rules, you can simply come in here, and one by one I'm going to go through, and I'm going to start by actually putting them all in at the same time. Now, it says which of the following functions, okay, which of the following functions. They want us to select one that goes up on the right and down on the left. So I typed in the first function here into decimals, and this is what it looks like. Now, if I make this a little bit smaller, I can see that on the right-hand side, it's heading up. It almost looks like it's going vertical, but it is slightly still diagonal. So it's heading up on the right, and it's heading down on the left, which makes the correct answer A, and I never had to take time to plug in the rest of the answers. If you've forgotten this, with all odd degree functions, which would be right here and right here, when the leading coefficient is positive, it's up on the right and down on the left. If that leading coefficient would have been negative with an odd, it'd be just the opposite. It'd be up on the left and down on the right. Now, what about even? Here's a 2 and a 6, even degree functions. When the number out front is negative, it means both sides go down. And when the number out front is positive, it means both sides have end behavior that goes up. Now, if you can't remember that, remember you can always just simply plug it into decimals and go one by one until you find one that matches the given. Which function has specific roots of -4, 1, and 2? A couple different ways we could do this. We could take each one of these values, such as -4. We could substitute in for the x's. And we want to know, when you substitute in this value of -4, which function here gives us an output of 0? And let's say we were able to eliminate a few choices. Then we go with 1, and we eliminate another choice. We do 2. Only one of these 4 equations can I input in -4, 1, or 2, and I will always get an answer of 0. That's an algebra breakaway to check. We also could do long division. Now, a way to check visually would be to plug this into decimals and find out, are the roots also known, the real roots also known as the x-intercepts, -4, 1, and 2. So let's start with A. I put in A, and here's, nope, I can see that one of the roots is not exactly -4, which means I can eliminate A. So I'm going to eliminate A, and now the only thing I have to change is I'm going to make, for option B, I'm going to make the 10 positive and the 4 positive. 10 positive and 4 positive. And again, I'm focusing on those x-intercepts. This time I have an x-intercept. Again, it's not -4, so I can eliminate B. And when I look at option C, I need to change the 10 into a -4 and the constant into a +8. I only have one option here. It's not negative 4. I can eliminate option C. And going down to option D would be negative 10 and positive 8. Okay, let's check. There's our negative 4, x-intercept of negative 4, of positive 1 and positive 2. Negative 4, positive 1, positive 2. Correct answer is D. And option number 5 states that we have is some type of a cubic function, and it tells us the leading coefficient is a negative 3. So remember, this goes back to what we talked about, in example number 3. So I have a leading coefficient that's negative, and I have also an exponent that is 3. So I have odd and then a negative. Now I just spoke to you and I said up before, it doesn't matter what the x-intercept is. When I look at this, I can simply plug in this, if you're a visual learner, and I'm going to look at the end behavior, and I can see that as I go to the right, I'm headed down, and as I go to the left, I'm headed up. So I'm going to draw just a little picture of that. As I go to the right, I'm headed down. As I go to the left, I'm headed up. Now, then what do you know about the end behavior? As you go to the right, what's happening? As you go to the right, it's headed down. Correct option is B. Which of the following functions is always decreasing except for, so one of these does not always decrease. The rest of them are always decreasing. So again, some of you may already understand kind of some of the basic understanding of these specific functions like cubic and linear, logarithmic, even degree function. But another way you can do this is you can simply plug it into Desmos. And so that's what I'm going to do right now. I'm going to start by plugging in the first one, and I'm going to check, is it decreasing? So we can tell if something's decreasing when we look from left to right, it's going down. So this is decreasing, which means I come back here and it says all of them are decreasing except for one of these. So I know that's decreasing, I cross it out. Then I go back to Desmos and I plug in option B, which was y equals negative 3, x to the third plus 2. Again, I can see this is continuously from left to right, it's going down, which means I get to cross out B. And by process of eliminations, I'm increasing the chance that I'm going to get this right. So I have two options left, and honestly, I'm going to go with whatever one looks easiest to plug in. I think D looks easier to plug in. So I'm going to come up here, and option D was a negative x to the sixth plus 3. Oh, okay. And here, although part of this is decreasing, I can see as I go to the right of x equals 0, it's decreasing when I look at it from left to right. Over here on the right-hand side, this portion is increasing. Remember, we analyze things from left to right. So it's increasing, and then it's decreasing. So this is not continuously decreasing, and that's what this says. It's always decreasing. This function is not always decreasing. That is the correct. Use the given graph of G to find all the roots and express it in factored form. So I'm going to have 3 different factors. That means 3 different parentheses. Now, I can already see one of the roots is 3. So I can come over here. Remember, we were at the opposite inside. So x minus 3 is one factor. I know there will be 2 other factors. Now, how can I figure out the other factors? Well, I know that they're not, by looking here, I know that they're not real roots. It means they're going to contain i's, the other 2. And here's how you find them. I know one of the roots is 3, and I'm going to choose to do, and you could use long division, I'm going to choose here to do what I called the mama method, or synthetic division. So here's 1x cubed minus 3x squared plus 2x minus 6. Remember, you bring down the first number here. So this should work. I should get a 0 in the end because I can see it's an x-intercept. It should work. So I bring down the 1 and I start multiply, and so on. This is the magic number I multiply back to. Multiply, add straight down. Multiply, add straight down. Multiply, add straight down. And it worked. And you may be thinking, like, why did you do that? You already know it worked. Because this other portion is going to help me figure out the other 2 remaining factors. Remember, this has no x's, this has 1, and this has 2. So I have 1x squared plus 0x plus 2 equals 0. All right, now you could solve by factoring, you could solve by completing the square, you may try to factor here, but the cool part is when you have no middle, there's even an easier way. When you have no middle, 0 times anything is 0, so I don't really have a middle term there. If I asked you to solve, the first thing you do is subtract 2 to the opposite side. Then you divide by 1, and I have x squared equals negative 2. Then I take the square root of it, and this gives me 2 answers. And you can't take the square root of a negative, so it sneaks up front and becomes an I. And then there's the square root of 2. Now the square root of 2 is not a perfect square, so that's what I have. Well, how do I write this? Well, I'm going to come up here, and just like I knew 3 was an answer, but when I put it inside, it had to lie. So I put negative 3. The same thing occurs here. So it's x, x, one's adding, one's subtracting, so it does just the opposite. So when I have the positive, that's one answer, and then here's the other answer. When I put this in, it goes in as the negative, and I'm going to put that I in front so it's not confused to be inside of the radical. And then the other one is a positive. This is factored form. You may be wondering, well, can I just leave it as this? Nope. Can I leave it as this and then just put the x squared plus 0x plus 2 here? Nope. It wants you to fully break it down. How did I know 3 parentheses? Because there were 3. H of x is a polynomial with a leading coefficient of negative 2, and it has the following roots. Write it in factored form. Oh, this is easy. Put down the leading coefficient, and I have 3 roots. Remember, each time it goes inside, it's going to lie. So the negative 4 becomes positive, the positive 4 becomes negative, and the positive 3 becomes negative. Multiplication here, the leading coefficient does not. Number 9 is going to be similar to number 8, but we're going to do a little more work because this doesn't say write it in factored form, it wants us to write it in standard form. That means first I write it out just like the last one. So as I put them inside, remember they're changing signs, and then I have to put it in standard form, which means I need to multiply this all out. So I'm going to start with just the first 2, and I'm going to FOIL front, outside, inside, and last. That's this portion. And I'm going to combine like terms. X squared, these 2 are going to cancel, minus 4. Okay, so in front I have a negative 3. I have an x squared minus 4. And in back, what I haven't touched yet is the x minus 4. I'm going to leave that negative 3 alone for now. And I'm going to FOIL this portion. Okay, here we go. Multiply in the front. And the order, then you multiply the back, front, outside, inside, and last. And our very last thing is going to be to distribute the negative 3. Negative 3x cubed, positive 12x squared, positive 12x, and negative 48. This is standard. Which of the following is not an even function? Well, I think it's important for us to understand what does it mean to be an even function. So I'm a visual learner personally. I'm going to show you a graph right now. And this happens to show us a picture of what it means to be an even function. So as I can see here, if I say x is 2, whether I go 2 to the left from the origin or 2 to the right, when I go up and I actually connect or intercept the graph, in this case it is a parabola, they're going to have the exact same y value. Let's look at the next picture here if I zoom in here. So if I look over here, if I go 1, 2, 3, if I go 3 places to the left, I'm at negative 1, and if I go 1, 2, 3, 3 places to the right, I'm also at negative 1. So in both cases, it's like I can fold along the y-axis and the 2 are identical. See over here? I can fold along the y-axis and the 1 is going to reflect upon the other. Okay, so let's keep that in mind here, and we're going to go back here. And I'm going to start by just simply plugging them in. So I'm going to start with the first one and work all the way down. So I've graphed these to save us time in this video. I've graphed these in Desmos, and I have actually deactivated option B, C, and D, so we only see option A. And as we saw in this previous one here, if we look back to this even and odd, I put in, as I told you, this line right here, the y-axis, also known as the equation x equals 0. I made that into a little dotted line so we could easily see if you fold along the dotted line, would the 2 lay on top of one another. Let's go and see. So here's this y-axis, and I can see that right here, this function. If I fold along this line, there's nothing that's going to reflect across it, right? It's not reflected across the line x equals 0, also known as the y-axis. So I know A is not working, but I do want to show you the rest. So let me deactivate A and bring B in. Well, B, I can see that if I am going to fold along the line x equals 0, known as the y-axis, the two are going to reflect across that. So it's considered an even function. So option B is a yes, but remember, we're looking for which one is not. So I already know A is not, but I just want to be able for you to visualize this. Let's bring out option C. Option C, again, if we fold along that orange line, I can see that they are going to reflect onto one another. And option D as well, they will reflect onto one another. So if I come back here, this was a yes, 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 and I'm looking for a no. Correct answer. Let's do problem number 11. I just wanted to refresh our memory. Let's take any, I don't care which one it is. Let's go with any quadratic function. Let's go let's start actually with an exponential function. Okay, here's exponential. How do I know it's exponential? Because a variable is in the exponent position. Now, if I asked you to find the inverse of this, I first switch the x and y, and then to solve for y, I have to take the log base 2 on both sides. Why log base 2? Because I'm trying to eliminate that 2. Remember, these are going to simplify to the 1. 1 times y is y. So how do these two functions, because they're inverses of one another, how do they relate? It means whatever the domain for this is becomes the range of this. And whatever the range is becomes the domain. So for instance, if I plug in a 0, anything to the 0 is 1. That means I know 1, 0 is here. And if I plug in a 2, for instance, I know 2 squared is 4. That means I know 4, 2 is over here. Okay, so keep that in mind. I have 4 different tables, and each table is going to match up to one of these, okay? So let's start by looking here. Well, if you have forgotten, linear, when we talk about first difference, the first difference of something, first difference means that as long as these are ordered and there is a general pattern, so I go from one number to the next, so 0, 1, 2, 3, 0, 1, 2, 3. When I look at the output values, I should be able to find a difference of 1. Difference of 1 is linear. So watch this. This is a difference of 1, but then a difference of 2, and then a difference of 3. Okay? But look at this one. Difference 1, difference is 1, difference is 1. When the difference is 1 in the outputs, the difference is consistently 1, that tells you it's linear. Now, to find, that's called the first difference, right? We only have to do it one time. Now, after we do the first difference, if we see a pattern, you're like, oh, I do see a pattern, then you do it again. So how do you get from 1 to 2? You go up 1. How do you get from 2 to 3? You go up 1 again. When the second difference is exactly the same, we say it's quadratic. I know this is stuff that's taught in Algebra 1, 2, but it's been a long time for many of you since you've had that information. Now, let's just talk about like a basic cubic. So a basic cubic looks something like this, right? Maybe a little more complex, but this is like the parent function for basic. So let's try, I can see this has a 0 and this has a 0. Let's see if any of these would happen to work. When I input in 0, 0 times itself 3 times, 0 times 0 times 0 is 0. 0, 0. Oh, maybe this does. Let's try 1. 1 times 1 times 1, 3 times 1 cubed is 1. 2 to the third gives you an output of 8. 3 to the third gives you an output of 27. Cubic is this choice. Now, look at this. Do you see how when I look at these two options, all I've done, or all that they've done here, is they've just simply taken the x and y's and flipped them. Look at, this was the input, it now becomes the output. This was the output, it now becomes the input. That's exactly like what we talked about before we did this problem. Okay? So how do I decide which one is exponential and which one is logarithmic? Okay, well, let's do that next. Exponential, we know, looks something like this. Some number raised to the x. So let's look at this. If I plug in 0, I get 1. Okay, that would make sense because it doesn't matter what number I have. If I plug in 1, I end up with an output, if I input in 0, so any number raised to 0 gives you an output of 1. Okay, this looks to be exponential right here. If I substitute in 1 for the input, what number raised to the first power gives you an answer of 3. Well, remember, when you raise a number to the first power, you're going to get that number. Like 3 to the first is 3, 4 to the first is 4, and so on. So 3 to the first is 3. That means that this should be like this. Let's just check here real quick. 3 raised to the 0 is 1. Good. Input is 1. 3 raised to the first is 3. Let's do 2. 3 raised to the second is 9. That's great. 3 raised to the third is 27. Now, is it essential you make up the equation as well? No, it's not. I just want you to be able to tell which one is exponential. We know the other one is logarithmic, okay? And it just happens to be that this is going to be the log of this function. So this is y equals log base 3 of x. You are not required to come up with an equation. You're simply required to take your 5 options and match them up. A graph of a function that has a leading coefficient of -2 and it has roots of -4 opposite, +4 opposite, and of 3. Remember, it's opposite. So I'm just going to plug it in just like that. So I'm going to come over here. I'm going to erase anything that was previously there. And we'll start with a -2, x plus 4. There is no need, excuse me here, there's no need to multiply this out. We just want to come up with a basic shape here and be able to identify some things on it. Okay, so this is what I have. I want to make sure I did this right. Oh, I got to click it in so it shows up. And I have roots, as I can see. It's down on the right, it's up on the left. Okay, down on the right, up on the left. Just seeing a basic shape here. What is that y-intercept? Whoa, it's way down here. The y is at 0 and -93. So if I had to do a basic sketch here, this is not going to be drawn to scale. Keep that in mind, not drawn to scale. I know it's down on the right, has 1, 2, 3, 4, -4, +4, 1, 2, 3, 4, +4, +3. Down on the right, up on the left, and it's going something like this. And it has a y-intercept of -96. Basic sketch. Let's look at number 13. Now we're going to sketch one that has a leading coefficient of -3, and it has roots of -2, +2, and 4. Remember, I'm switching the signs as I write it down. So I'm going to go back here into decimals. -3 instead of a -2 is that leading coefficient. Remember, the leading coefficient does not change signs when you put it in. -2, +2, and -4. So what do we know here? This time we have a y-intercept of -48, and this time -48. So I'm going to come back here. Again, it is up on the left, down on the right, and -48 is the y-intercept. So, okay. I'm going to go to -2, 1, 2, over 1, 2, over 4, 3, 4. Okay, down on the left, up on the right. So it's looking something like this. And this is I believe I said 48, but let me check just to make sure. I can come down here, wheel all the way down, click on that, and it is a -48.